This is kind of how we end up we usually finish up the school year with is acid-base chemistry. There's a couple lab procedures you guys are going to miss out on, obviously, because we can't be here. So what I'm going to do to make my life a little bit easier next year is just tell you the basics of what most the acids that we deal with look like and what most of the base we deal with look like. Okay, so there's three theories of acid-base chemistry. The first one, and the only one we're going to talk about, literally the only one, is the Arrhenius theory. And then I'm going to show you guys how to use your calculators to calculate something called pH, which you've probably heard of, and pOH, which you probably have not heard of. So we'll start with Arrhenius acids and bases. What makes an Arrhenius acid? It's something that has hydrogen in it. And it's a hydrogen-containing compound that when you put it into water, make a solution, it ionizes into H plus ions. So H plus ions are very important in chemistry, biochemistry, biology. You learned about it with probably passive and active transport. There's something called a proton pump in biological systems. What a proton is an H plus. So you're like, what proton? That's in the nucleus. But an H plus, if you think about it, H is hydrogen. Hydrogen is normally a proton and an electron. But if you remove the electron and you have the leftover positive charge, literally that's a proton. So when an acid is chemically reacting with something, an Arrhenius acid, it's a proton that's reacting with. So if you get a chemical burn from Arrhenius acid, it's because you have these little protons that are reacting with you, basically pulling electrons from different places and such. Okay. An Arrhenius base is something that has OH in it. It's a compound that ionizes into OH minus ions. So you have H plus ions, you have OH minus ions. So Arrhenius bases are things that usually in their formula they end in OH. I'll show you guys some examples today. Okay, so, and I'm not sure how much acid-base chemistry you guys have had. I know in 8th grade, you do things with litmus paper. You take this weird colored paper, you go, oh, it turns blue or it turns red, and it tells you if it's an acid or a base. We're going to go into a little bit more detail on that. So an Arrhenius acid, when it's in solution, is a chemical for right now. Like I said, this is a very, very overly simplified version of this, but like I said, you guys are at home and it's tough to learn this stuff, especially when I'm only doing 1 or 2 lessons a week. It's an acid that has H written at the beginning. So like what I tell my Chem 2 students is like when they're identifying acids versus bases, the first thing to do is look for H's written at the beginning. So there's some examples of chemicals that are Arrhenius acids. The one that we deal with a lot is HCl. It's called hydrochloric acid. You have H2SO4. H2SO4 is called sulfuric acid. So sometimes used in like car batteries. The next one that looks really, really beefy, HC2H3O2, is called acetic acid. And that is kind of the thing that makes vinegar acidic. Nitric acid is another acid that can mess you up if it's super concentrated, HNO3. So you'll notice that all of those things, even the weird one, the one that has H's in the middle, these things all have an H at the beginning. Okay? And the key is that when you put these things into water, they break into H plus. They break into H plus. So those little H pluses, if an acid's chemically reacting with something, it's that H plus or that proton that's doing the reacting. An Arrhenius base, it has OH written. It's usually written at the end. So Arrhenius bases are usually metals with OH. So you have LiOH, KOH, NaOH. These are called lithium hydroxide, potassium hydroxide, sodium hydroxide. Sometimes you can have more than one OH, like with calcium hydroxide or magnesium hydroxide. So for us, these guys are going to be bases. Okay? When these guys are in solution, the key about them is that they make OH minuses. So little OH minuses that are swimming around. So like people think acids are always worse than bases. Sometimes you can have, there's some bases that can really mess you up. Sodium hydroxide being one of them. So if you get a chemical burn from sodium hydroxide, it's because these little negative OHs are messing with you. They're chemically reacting with you. Okay. So what we do in terms of acid-base chemistry down the road is with a lot of solutions, there's stuff in them, and we kind of want to know if they're acidic, or we use the word basic, or we can use the word alkaline. So the scale that you guys are probably familiar with is one called the pH scale. The pH scale. So the pH scale is traditionally 0 to 14. That doesn't mean you can't have negative pHs, and that doesn't mean you can't have pHs that are greater than 14. Okay? What the pH scale measures is H+. pH measures H+. So 7 is the neutral position. 7's kind of like right in the middle of this. So pure water is an example of this. Not tap water. Tap water sometimes has some stuff dissolved in it that can shift the pH. When we talk about pure water, we're talking about just H2O. H2O, distilled water, 7 is right in the middle of that. Okay? So if you go below 7, you're on the acidic side of the scale. And we'll talk about how to calculate these today, or a very simplified version of calculating these. So acids are going to be below 7, which means bases are above 7. Okay? So the way we calculate this, and this is going to be based on your calculators, so you guys are going to have to kind of pay attention to this. So if you do have issues, we'll do an example today. If you do have issues, holler at me, because some calculators you have to do it in a different order. Depends on what type of calculator you have. Okay, so to calculate the pH, you're going to, now I don't want you to freak out, especially if you've been in algebra 2 or like trig or any of that stuff. The log button for us is literally just a button. So we're going to push the negative sign, not the subtraction, but the negative sign. Then we're going to find the log button, and then we're going to type in the concentration of the H+. So what that H+ and little brackets means is the H+ is concentration in molarity, which for right now, like I said, is going to be given to you. So we can see if we're all on the same wavelength here. We're going to try to find the pH if we have a concentration of 0.100 molar H+. Okay, so this is going to tell me what type of calculator you have, depending on how your calculator is organized. So if you have a calculator that when you push the log button, it says log, you are literally going to type this in, negative sign log 0.1. Okay, so negative sign or the log button and 0.1, and you're going to hit enter, and it's going to say 1. Now, if you have a calculator that does not say the word log when you type log, you have to do it in the exact opposite order. Sorry about that. So you have to type in 0.1, push the log button, and then push the negative sign. So I got 1 for an answer. So if you did not get 1 and you are struggling with this, you should unmute right now and holler at me. Okay. What questions do you have, if you have any? Anything? So I don't know if you guys can see this on the board here. The key to doing the pH scale is that you're given H+. If you're not given the H+, then you can't type this in and expect to get pH. Okay, I'm going to show you the other scale, and I'm going to show you guys how these guys tie in together. So let's see here. Let's go here. go to the next slide. Now this scale you've probably never heard of. It's called the pOH scale. And instead of measuring H plus, it's more conveniently used for things that are bases. So it's the same idea as pH, but it's the opposite. It measures OH minus, and the scale is flipped. So instead of below 7 being acidic, on the pOH scale, 0 to 7 is basic. Actually, 7 is right in the middle, so I didn't really type that in very well. Okay, understand that 7 is perfectly neutral on this scale as well. So below 7 is a base, and above 7 is an acid. So to calculate the pOH of something, all you do is you take the negative log of the OH minus. So if you're given OH minus values, it's more convenient for you to find the pOH of something. If you're given H plus values, it's more convenient for you to use the pH. So it's literally the same equation, and you are going to, like I said, based on your calculator, type it in however you need to. Okay, so find the pOH if you have 1.2 times 10 to the negative 2 molar OH. Oh my. A lot of times our concentration of OHs and H pluses can be very small. Okay. Let's say you don't want to type that in scientific notation. Just go ahead and move the decimal a couple of places to the left if you want to type that value in. So we would type in the negative log of 1.2 times 10 negative 2, or you could do the negative log of let's see, what is that? 0.12, I believe. So the pOH that I got is 1.92. Do not worry about sig figs when it comes to pHs for right now. I'm not going to worry about that, or pOHs. Okay. I got 1.92. So that tells me that whatever this solution is, because the pOH is less than 7, that this solution must be a base. In the previous one, where we got a pH of 1, that tells me that that solution was an acid. If you have questions at any point, just holler at me, okay? Now, what we're going to do is we're going to tie these two things together, and the common thread is that these guys are related to each other. pOH and pH are related to each other through this concept. Any solution that you have, any solution that's dissolved in water, the pH and the pOH are always equal to 14. The pH and the pOH are always equal to 14. So this is how you can take the pH of one solution and you can figure out the pOH of that same solution, and vice versa. Okay? So for the first one that we did, where we said the pH was 1, that means the pOH of that solution is 13. There you go. That's your very simplified version of acid base. Okay, so if you know one, you can find the other. So on your assignment, you're going to have some H plus values given to you where you'll find the pH. You have some OH values where you'll find the pOH. And then you'll have, maybe I give you a H plus value and I ask for the pOH. So you got to find the pH first and then subtract from 14 to get the pOH, and vice versa. Okay? I hope I said that right. We'll see how that goes. Okay? So that's our super speedy lesson today.